Hi everyone. So we'll have a continuation of the next session. So this class we're going to learn about how to apply a current division rule. How to apply a current division rule. So this plays a major role in finding out current across any branch. For example, your resistor is given. If you want to find the current across this branch, you can find out with the help of current division rule. Let's try to see the formula of current division rule. Consider you have an resistance R1 and a resistance R2. So this is resistor R1, this is resistor R2, and these two are excited with an DC supply. Let us assume the total current in the network is of I amperes. The current in R1 is of I1 amperes. The current in this branch is of I2 amperes. Now I want to find out the values of I1 as well as I want to find the values of I2. Let us first try to define the formula of I1. So how to find the current I1. So current I1 directly from the formula we know that so total current multiplied, where the total current is nothing but I multiplied. So for example, here you are going to find the current I1. So product of opposite branch resistor, which is also called as a parallel resistor, parallel resistor. Okay, so we require the parallel resistor. For example, we are finding the a current I1 here, but the parallel resistance to this, which is nothing but R2. So parallel resistor is nothing but R2 divided by the sum of resistors which are connected in parallel. So what is the sum of resistor? Is nothing but R1 is one parallel resistor, R2 is the another parallel resistor, where I am going to call as the sum of resistors connected in parallel. So this is what the formula of finding out the current across an branch. Let's try to apply for an problem. So the formula to find the current across the resistor R1 is this one. Let's try to recall the current. So the current I1 is nothing but total current of the network, which is nothing but the I amperes of current multiplied by parallel resistor. What is the parallel resistor of I1? Is nothing but R2 resistor is nothing but into R2 divided by the sum of resistors connected in parallel. So what are the two resistors which are connected in parallel? R1 and R2 are the two resistors connected in parallel. So similarly, I would like to find out I2. So how to find out I2? So I2 is also the same way of application. So I2 is nothing. What is the total resistance of the branch? What is the total current of the branch? This is I amperes. So I want to find the current I2. So what is the resistor in parallel to R2, which is nothing but R1 divided by the sum of resistors which are connected in parallel. So those two resistors are R1 plus R2. So this is how to find out the current I1 as well as the current I2. Let us try to solve with an example such a way that it will be clear how to apply. Okay, so take a resistive network which consists of two resistors which are connected in parallel, and let us try to solve it. Let's take an network. See here, we have an current source, and here I am going to have two resistors. This is resistor 1 and resistor 2, and these are connected in parallel. Here I have one more parallel branch. This is one resistor and this is another resistor, and these two are again connected in parallel. So now let us give the names. So this is of 5 ohm, this is of 2 ohm, this is of also 2 ohm, and this is of also 1 ohm. So now let's try to find out so now so this is a given circuit for us, and they are asking us to find out mark the currents as I1, the current as I2, the current as some I3, and current as I4. And the question itself, it is given the total current is 10 amperes. So now what is the total current in the network? 10 amperes. So he's asking us find the values of I1, find the values of I2, find the values of I3, find the values of I4. This is what the given circuit diagram is there, and he's asking us to find out I1 and I2. So coming to the application, sir, how to find out the current I1? So what is the formula of I1? I1 is equal to total source current. What is the total source current? 10 amperes multiplied by. So here I am finding the I1. What is the resistor in parallel to the 5 ohm, which is nothing but 2 ohm. This is nothing but 2 ohm divided by the sum of resistors which are connected in parallel. What are the two resistors connected in parallel? This is nothing but 5 plus 2. This is how to find out I1. So coming to I2, so I2 is also the same formula. So I want the current in this branch. So the branch current can be find out like this. Okay, so how to find out I2? I2 is nothing but the formula is total current of the network. What is the total current of the network? Which is nothing but 10 amperes multiplied with. So in this branch we require the current. What is the branch in parallel to I2 resistor? Is nothing but 5 ohm. So multiplied with 5 ohm divided by, so what are the two resistors which are connected in parallel? Which is nothing but 5 plus 2. So when you perform the calculation for this, you are going to get 2.87 amperes. This you are going to get it as 7.14 amperes. So coming to the next part of finding out I2 and I3. So now we need to find out I3. So how to find out I3? So here 10 amps current is entering. Okay. So in this 10 ampere current, you can see here 7.14 and 2.8, approximately 7 plus 3. So total current in this network is also how many amperes? 10 amperes. Okay. So now I want to find out the I3 and I4 here. So I3 is equal to, so I3 is equal to, what is the total current in the network, which is again 10 amperes multiplied with. So here the current I3 I require. What is the branch in parallel to the I3 branch, which is nothing but 2 ohms divided by the sum of resistors which are connected in parallel. What are the resistors which are connected in parallel? So one is 1 ohm plus 2 ohm. Okay. So then you will get I3. So how to find out the current I4? I4 is equal to, so I want the current in this branch. How to find the current in this branch? So here you can write down what is the total current of the network, which is nothing but 10 amperes multiplied with. So here I4 current I require. What is the branch opposite to I4 branch, which is nothing but 1 divided by the sum of resistors which are connected in parallel. What are the resistors connected in parallel? Is nothing but 1 plus 2. So when you perform the calculation, then you are going to get these values. So this is you are going to get this as a 6 point, you are going to get it as a 6.66 amperes, and here you are going to get it as a 3.33 amperes. So 6.66 is nothing but 6.66 plus 3.3, which is also equal to 10 amperes. So that's how successfully we find the value of I3, and that's how we find the value of I4. The addition of I3 plus I4 will be equal to 10 amperes. The addition of I1 and I2, the addition of I1 and I2, which is 3 amperes and 7 amperes, will be equal to the resultant current 10 amperes. This is I1 plus I2. You can see here the current entering is entering it as I1 and I2. So this current I am going to call it as I1 plus I2. So the addition of these two currents we are getting I1. That's how our circuit is verified. So if you want to redraw it circuit, I can redraw it for you. So what is the formula we got is, so what is the source current is 10 amperes, and we already identified the currents in this resistive branch and I1 and I2, and you are going to get a parallel branch, and here what is the amount of current I1, 2.87 amperes. What is the current here? 7.14 amperes. And what is the current in this branch? 6.66 amperes. The current in this branch is 3.3. So if you, what is the total current in this branch? So this is nothing but entering current is equal to leaving currents. So this Ix can be written as 6.66 plus 3.33. So where the total current, already we know that what is the total current, already is 10 amperes. So what is the total current here? So if you add, so 10 amperes should be equal to, what is this one current? 2.87 plus 7.14, which is already equal to 10 amperes and 10 amperes. So 10 amperes is entering and 10 amperes is leaving. This is how to apply a current division rule. Let's come to the next problem. So keep it in the mind. Note, we can apply current division rule only when we have two parallel branches. For example, if you have only two parallel branches, with I1 current and I2 current, then only we can apply current division. This is the main drawback. Okay, let's try to find out. There are some other methods like nodal method to find out. Let's try to solve one more problem. So which is comes under example 2. So the question which is given to us is like this. So they are claiming that they have one voltage source, they have one parallel resistor like this, and one more parallel resistor like this, and one more parallel resistor like this. So the given problem is input voltage is 48 and which develops a current of 18 amperes, and the given values are 12 ohms, and the given values are 6 ohm, and the given values are 8 ohm, and it's already marked in the question. The current in this branch is I1, the current in this branch is I2, the current in this branch is I3. Now let us try to find out. Is asking us find the values of I1, I2 and I3 and verify Kirchhoff's current law. So this is what the question given. Let's try to solve it. Already we know the formula of finding out the current. So we need to find out the current I1. Sir, how to find the current I1? Here you can see here 12 ohms and 6 ohm and 8 ohm are connected in parallel. All the three resistors are connected in parallel. You see here what is the voltage at this point? 48 volts, 0 volts. What is the voltage at this point? 48 volts, 0 volts. What is the voltage at this point? 48 volts, 0 volts. What is the voltage at this point? 48 volts, 0 volts. Now let us try to solve it. So now we need to find out the current I1. So how to find the current I1? So current I1, if you want to find out, we have to redraw the circuit. So same voltage source we have, and we want to find the current I1. So I'm drawing that branch. So here the total current is given as 18 amperes. The voltage given is 48 volts, and in this branch we need to find out the current I1. And now, so with respect to these two parallel branches, we have to draw one parallel branch. I'm redrawing that parallel branches, and already it is told 6 ohm and 8 ohm are connected in parallel. The equivalent of these two parallel branches is 6 into 8 divided by 6 plus 8. So when you perform this, you are going to get it as some 2.5 ohms. So now I think we are very confident. You have only two branches to find out. So how to find out the current I1? Current I1 is equal to, so what is the total current given in the problem, which is nothing but 18 amperes. 18 amperes. So this is not 3.2, this is 3.42 ohms. So this is 18 amperes into, so what is the opposite branch we are having here? The opposite branch is 3.42 ohms divided by the sum of resistors which are connected in parallel. What is the two resistors? So this is 12 ohms in parallel with the next branch is how much? 3.42. So when you try to add these ohms and ohms will get cancelled and you will get the current. Therefore, you are going to get the current is some 4 amperes. Similarly, let's try to find out the current I2. So how to find out current I2? So how to find the current I2? The same circuit diagram you are going to have. You are going to apply an voltage of, actually voltage also not required. Why? Because current is directly given 18 amperes, and here we are going to have the branch which is nothing but a 6 ohm resistive branch. 6 ohm resistive branch, as you can see here. So this value you are going to find out 6 ohm, where 12 as well as 8 are connected in, 12 and 8 are connected in parallel. So now this resistor I am drawing where, so now how to identify it? You see here, this 12 and 8 are in parallel now. So the central limb is a 6 ohm, and here we are going to have the product 12 into 8, product of resistance divided by sum of resistors. When you perform this, you are going to get 4.8 ohms. So we need to find out, the target is to find the current I2. Therefore, the current I2 is equal to, total current is 18 amperes multiplied with, so we require the current in this branch. What is the opposite branch resistor? Which is nothing but 4.8 ohms divided by the sum of resistors which are connected in parallel. So what are the two resistors connected in parallel? 6 plus 4.8 ohms. When you perform the calculation, you are going to get it as 8 amperes. Now coming to the next one. So here we want to find the current I3. Okay, so if you want to find the current I3, these two branches are connected in parallel. So let us try to solve it. How to solve I3? So you have an voltage source and the total current given to is 18 amperes, and here we have one resistor, and here we have the next resistor, which is nothing but the current in this branch is I3, which is nothing but 8 ohms. You can see from here, copy from the board. So we need to find for 8 amperes. Now what are in parallel? So 12 ohms and 6 ohms are in parallel. 12 ohms and 6 ohms are in parallel. So I can write down 12 into 6 divided by 12 plus 6. So when you perform it, you are going to get it as 4 amperes. Now it is a straightforward question for you to understand well. So how to find out the current I3? So current I3 is equal to, what is the total current given in the network? 18 amperes multiplied with, opposite the parallel branch resistance, which is nothing but 4 ohms divided by 4 ohms plus 8 ohms, which is nothing but 4 plus 8. So we are going to get this as 6 ohms. So let's try to construct the total diagram. So given circuit diagram is 48 volts and given current is, as per our calculation, 18 amps. You have one branch here and the current is I1, and you have one more branch here, the current is I2, and you have one more branch here, the current is I3, with the values of 12 ohms, with the values of 6 ohm, with the values of 8 ohm. And I1 value you had already find out, this is 4 amperes, this is 4 amperes, I2 is 8 ampere, and I3 is 6 amperes. Now let's try to apply the KCL at node 1. Try to apply KCL at node 1. When you apply the KCL at node 1, so apply Kirchhoff's current law at node 1. So when you apply it, you see here, so what is the current in this branch? So I can write down, I want to find this current Ix. So how to write the current Ix? Ix is the entering current. What are the leaving? You apply the KCL at this point also at node 2. So initially at 1 you will apply later. Now let's try to apply it node 2. At node 2, what are the entering currents and what are the leaving currents? So I don't know this current, that's why I'm writing this current as Ix. And what are the leaving currents? You can see here, this is one leaving current and this is another leaving current. I can write down it as I2 plus I3. Therefore, Ix is nothing but I1 plus I2. Or if you are very clear, you see here, entering currents is equal to leaving currents. Okay, I2 plus I3 if you add, sorry, I2 plus I3 if you add, then you will get this branch current. But I want to apply it to node 1. Now apply the same KVL at node 1. So what is the entering current? So the entering current to node 1 is nothing but how much? 18 amperes. What are the leaving currents? You can see here I1 is leaving. There is nothing but 4 amperes plus. So here this is also leaving, which is nothing but I2 plus I3. So already you know this. I1 is of how much? 4 amperes. And what is the value of I2? I2, what is the value of I2 you got? 8 ohms. And what is the value of I3 you got? 6. So just you add 10 plus 8, 18 ohms and, sorry, 18 amperes and 18 amperes. So I can say that as per the given question, the Kirchhoff's current law is verified. And today we have learned this Kirchhoff's current law, and you learn how to apply current division rule for a two branches connected in parallel and three branch resistors connected in parallel. So this is what the target we have been learned today, how to verify a KVL and how to apply a current division rule for two branches connected in parallel and three branches in connected parallel. You can practice it for four branches connected in parallel. So hope, so by this session you are clear about this current division rule. So if you feel the video is useful, please like, share and subscribe to our YouTube channel and share with your friends also. So thank you for bearing with us to understand the concept. Thank you.